Don't waste your precious time and energy wishing things were different. Things are as they are. Stop complaining, instead, start doing. Positive thoughts for a very positive day, everyone. I am your Mathematics 10 teacher, Melane Magadan-Gelsano of Nabunturan National Comprehensive High School, Nabunturan West District. After watching this episode, Grade 10 learners are expected to: first, find the combinations of n objects taken r at a time. Second, solve problems involving combinations. And last, identify situations that describe combinations and relate to real-life situations. Today, let me share to you topics about combinations. Before we start, prepare your Mathematics 10 Quarter 3 Module 2, pen and paper. Let's get ready! Suppose you are given a situation. Kindly identify if it is permutation or not. Number 1. Determining the top 3 students in a class. Correct! It is a permutation. Number 2. Entering the PIN of an ATM card. Very good! The situation involves permutation. Number 3. Random testing on COVID-19 for senior citizens. Right! It is not a permutation. Number 4. Matching blouses and skirts. Awesome! It is not a permutation. And number 5, the plate number of vehicles. Permutation, you are right again. In our previous lesson, we were able to illustrate permutation. When the arrangement of objects is important, then it is permutation. But if the arrangement of objects is not necessary, then it is said to be a combination. In the next activity, I will show you how to solve problems using the combination of n objects taken r at a time. First example. In how many ways can a medical practitioner test COVID-19 for 5 senior citizens, one at a time? This problem can be solved through listing method. Say we have senior citizens A, B, C, D, and E. Then, there are 5 possible ways a medical practitioner can test these senior citizens since it is taken one at a time. Another way of solving the problem is using the combination formula. The number of combinations of n objects taken r at a time is denoted and defined as C quantity nr equals n factorial over r factorial times quantity n minus r factorial, where n equals the number of objects, r equals rate or the number taken at a time, and n is greater than or equal to r, and r should be greater than or equal to 0. Since there are 5 senior citizens taken one at a time, so n equals 5 and r equals 1. Using the combination formula, we have C quantity 5(1) equals 5 factorial over 1 factorial quantity 5 minus 1 factorial. Then 5 factorial over 1 factorial, and 5 minus 1 is 4 factorial. Then 5 factorial is equal to 5 times 4 times 3 times 2 times 1 over 1 factorial is equal to 1 times 4 factorial, which is equal to 4 times 3 times 2 times 1. So, C quantity 5(1) is equal to 5 possible ways. Therefore, the same as the listing method, using the combination formula, there are 5 possible ways a medical practitioner can test 5 senior citizens, one at a time. Second example. What if the 5 senior citizens will be tested for COVID-19 5 at a time? Can you guess? Correct! Only one possible way, because the 5 seniors are tested for COVID-19 at the same time. Let us check using the combination formula. 5 seniors taken 5 at a time, so we have n equals 5 and r equals 5. So, C quantity 5 equals 5 factorial over 5 factorial quantity 5 minus 5 factorial. Then, 5 factorial over 5 factorial times 0 factorial. Take note that 0 factorial equals 1. So, 5 factorial over 5 factorial times 1, we have C quantity 5 equals 1 possible way. Third example. In combination of 7 objects taken 7 at a time, where n equals 7 and r equals 7, then C quantity 7 equals 7 factorial over 7 factorial quantity 7 minus 7 factorial. Next, 7 factorial over 7 factorial times 0 factorial. Next, 7 factorial over 7 factorial times 1. Again, take note that 0 factorial is equal to 1. Therefore, C quantity 7 equals 1 possible way. Fourth example. How about combination of 7 objects taken one at a time, where n equals 7 and r equals 1? Then, C quantity 7 equals 7 factorial over 1 factorial quantity 7 minus 1 factorial. Then, 7 factorial over 1 factorial times 6 factorial. Next, 7 times 6 factorial over 1 factorial times 6 factorial. So we have C quantity 7, 1 equals 7 possible ways. Based on the given examples, we can conclude that the combination of n objects taken all at a time is C quantity n equals 1, while combination of n objects taken one at a time is C quantity n 1 equals n. Another example. How many ways can we create a committee of 3 frontliners from 5 health workers? Here's how. By listing method, we let Amy, Ben, Cecil, Dan, and Wang are the health workers. So we can have the following: Amy, Ben, and Cecil, Amy, Dan, and Wang, Amy, Ben, and Dan, Ben, Cecil, and Dan, Amy, Ben, and Wang, Ben, Cecil, and Wang, Amy, Cecil, and Dan, Ben, Dan, and Wang, Amy, Cecil, and Wang, and last, Cecil, Dan, and Wang. So, there are 10 possible ways. By combination method, we have the formula C quantity nr equals n factorial over r factorial quantity n minus r factorial, where n equals 5 and r equals 3. So by substitution, we have C quantity 5, 3 equals 5 factorial over 3 factorial quantity 5 minus 3 factorial. Next, 5 factorial over 3 factorial times 2 factorial. Next, 5 factorial is 5 times 4 times 3 times 2 times 1 over 3 factorial, which is 3 times 2 times 1 times 2 factorial, that is 2 times 1. So we have 20 divided by 2, and that is equal to 10. Therefore, there are 10 possible ways of creating a committee of 3 frontliners from 5 health workers. Want more? Okay, last example. Suppose the Nabunturan Youth Federation will hold a basketball tournament, and there are 6 participating teams. If each team must play every other team in the elimination round, how many elimination games will there be? By listing method, we let A, B, C, D, E, and F be the 6 participating teams. Among the 6 teams, 2 teams will play at a time. So we have teams AB, BC, CE, AC, BD, CF, AD, BE, DE, AE, BF, DF, AF, CD, EF. So, there are 15 elimination games during the tournament. By combination formula, again, we have C quantity NR equals N factorial over R factorial quantity N minus R factorial, where N is equal to 6 and R is equal to 2. Next, we have C quantity 6, 2 equals 6 factorial over 2 factorial quantity 6 minus 2 factorial by substitution. Next, 6 factorial over 2 factorial times 4 factorial. Next, 6 factorial is 6 times 5 times 4 times 3 times 2 times 1 over 2 factorial, which is 2 times 1 times 4 factorial, which is 4 times 3 times 2 times 1. So we have 30 divided by 2. And C quantity 6, 2 is equal to 15. Therefore, there are 15 elimination games during the tournament. How did you find the listing method? Easy, right? Yes, but listing method is best only if the number of objects taken are few. Still, the use of combination formula in solving problems is much more easier and effective. Now let us practice. You may use any method convenient for you. Got your paper and pen? Are you ready? Number 1. Combination of 4 objects taken 3 at a time. Yes, 4 possible ways is correct. Number 2. Combination of 5 objects taken 2 at a time. Very good! 5 ways. Number 3. Combination of 6 objects taken 6 all the time. Correct! Only 1 way. Number 4. Combination of 7 objects taken 4 at a time. Awesome! 35 ways. And last, number 5. Combination of 10 objects taken 5 at a time. 252 ways. You are correct. You've done great. The lesson in combinations may be used in real-life situations, in groupings, creating committees, games, and more. You can do the listing or use the formula. Either way is helpful. Did you enjoy the lesson? As they always say, practice makes perfect. Everything is a learning process. Every time we fall, it's just teaching us to stand up the next time. Thank you for watching. Once again, this is your Mathematics 10 teacher, Melane Magadan-Gelsano of Nabunturan National Comprehensive High School, Nabunturan West District. Until next time, always remember, dito sa TV Eskwela, sa pag-aaral, sama-sama. Bye-bye!